Hi friends, welcome back. Now let's get into the various scheduling algorithms we have in store for scheduling the processes. This is required when we have more number of processes than the number of CPUs available, and we need to ensure that all the processes, all the threads get a fair chance to run. So that's what scheduling algorithms are. Just a glimpse of various types of scheduling algorithm. Two types of scheduling algorithms: preemptive, non-preemptive. In preemptive type of scheduling, a process can be stopped in between and another process may be accommodated, whereas in non-preemptive, once a process is allotted CPU, till end of that process CPU will be with that particular process. So the common examples for preemptive are priority scheduling, round robin scheduling, and the common examples for the non-preemptive are the first come first served, shortest job first, and so on. So let's dive into the various types of scheduling algorithms we have, and then look at what they mean to different situations, and then see what type of situations are better for a given scheduling algorithm, and what are problems with the scheduling algorithm, pros and cons, and all that in detail one by one. So let's begin with the simplest logic, that is the first comes first served type of scheduling. It's a non-preemptive scheduling algorithm where the process that arrives first will get the chance to use the CPU first, and it doesn't matter how long it takes to run the process. So the process time doesn't make any sense here. What makes sense here is only the arrival time. The one which comes first will get the chance first to run, and it is a non-preemptive. That means once a process gets a chance, till the end it will continue to run. So the example would be a simple queue at a ticket counter. So the one who comes to the counter first will get the ticket first. Doesn't matter how long a person stays at the window, but the only qualification is the one who arrived first will get the ticket first. That's it. And the processes are ordered by their arrival time. There's nothing to do with the process time. It only matters is the arrival time, and once a process gets the CPU, it runs to the completion. So till the process is complete, it is going to continue to run. The same process will continue to run till it completes its work, and the next process in the queue starts only after the previous one finishes its work. Till the previous one finishes, the next one will not get the chance to run. A simple example would be, we have three processes P1, P2, P3, and the runtime burst time is first one is 24, second one is 3, third one is 3, and the figure shows here that P1 has come first, therefore P1 gets chance first. So P1 occupies 24 slots of time. Only after 24 slots of time P2 comes into picture, because P2 is the second one to arrive, and P2 runs from 24 to 27, and then P3 gets its chance, and P3 goes for 3 more time slots. Now if we want to know what is the average waiting time and all that, P1 immediately started executing, therefore there is nothing to wait. So the waiting time for P1 is 0, and P2 had to wait till P1 completes, therefore waiting time for P2 is 24, and P3 starts only at 27, therefore the waiting time for P3 is 27. So the average waiting time, if you look at it, is somewhere around 17 units of time. So the advantages of first come first served: simple to implement, fair, the processes are served in the order they arrive, so the way they arrive, the same way they will be run. And this is good for batch systems, where jobs are of similar size. So usually the batch systems where jobs are of similar size, we can prefer to use first come first served type of scheduling. Yes, of course there are disadvantages with it, and there is a convoy effect. That is, one long process is going to delay all others. Just last example we have seen, the first process was 24 units of time, whereas the other two were only 3 units of time, but still the first one got 24 units of time, the other two have to wait for a very long period. So that's a convoy effect. So one long process is going to delay all others. And definitely there is poor average waiting time if the jobs vary in length, as we have seen in the previous case. First job was of very long size, second job, third job were of small sizes. So size uh, of each job is different, and because of that the average waiting time could be poor. And there is definitely no preemption, so it is not good for interactive systems. Just imagine that our system is working on a multi-processor, multi-process, multi-thread configuration, and any given time one process or one thread is working. And if you assume that our current system is working on no non-preemptive type of scheduling, and current status of the current job, whatever it is doing, if it is taking almost infinitely long time, then you do anything, whether you hit the mouse button, whether you hit the keyboard, do whatever you like, it's not going to respond, because our processor is busy working with one process, and that one process is taking very long time. And hence, when we are working on interactive systems, definitely this non-preemptive type of scheduling is a little annoying, creates too much of irritation, because it's not responding immediately, because in the background some other process is running, and whatever process which is to run for clicking of this particular mouse or clicking any keyboard button, whatever process has to work, and that process will not come onto picture, because that will not be scheduled, as this current scheduled job is taking quite a long time. So that's going to be a highly irritating situation. So that's one issue. If the first job is too long, then it's going to create a problem to all other jobs, and because of no preemption, this another problem we do have. So looking at the convoy effect, it occurs when a long running process holds the CPU or a resource, causing shorter, faster processes to move unnecessarily, wait for a very long time. This is going to lead to poor CPU utilization, very low throughput, and definitely very high waiting time. So what is happening here is that the first process itself is taking very long time to run, and this is holding the CPU, or any process is holding a particular resource. Then any other processes which want to use CPU or resources for a short period have to wait unnecessarily till this currently running process completes its job, and hence the CPU utilization goes down, and definitely the throughput is low, because in a given time the number of processes completed is going to be low, and definitely each one is forced to wait long period, and hence waiting time is going to increase. So as an example, if you look at it, it is like a slow moving truck on a one lane road. So there is one lane road, and in that one lane road a slowly moving truck is going, and behind that truck any faster cars or the bikes which could have run faster than that are stuck behind it. So that's going to be big problem, and it's what we call a convoy effect. So that's one major problem with first come first serve, because it is whichever comes first will be served first, and for some reason, or if the first job is too long, then each one is going to get affected, and that leads to CPU utilization, low throughput, and very high waiting time. So that's about first come first serve. Other scheduling algorithms to follow. Please keep watching. Thank you.